tutorial series of the operating system. I am your instructor Varshata. Let's start our lecture series. So topics to be covered in today's lecture, that is what is scheduling, objectives of scheduling, then we will see the process scheduling queue, and then we will see which are the different types of scheduler. Okay, so till now we have discussed about the what is process, what is program. So today we will see if the process is there in the execution, then how this process scheduling can happen, and if there are multiple processes are there in the execution, which process this CPU will choose for the executions. So first of all, let's learn what is scheduling. So here the process scheduling is the activity of the process manager that handles the suspension of running process from CPU and selection of another process on the basis of the priority on the basis of the particular strategy. Okay, it may be priority, it may be the shortest job, it may be the first come first serve. So depends on the particular strategy, the CPU will choose the another process. So exactly the role of the process process scheduling is what? The schedule the process. That means the process that is now running, we have to stop the executions of that process and we have to select the another process for the executions. It is because it may be there are numbers of reasons. For example, the process has completed its executions, otherwise any input output interrupt has occurred, otherwise if the process is not able to complete its executions. So there are the numbers of reasons why we have to suspend the process. Okay, so if any process suspension is there, then we have to select the another process for the executions. Or it may be possible we have defined the time quantum that for the 3 seconds this process will go for the execution, for another 3 seconds this process will go for the executions. So that is what depends on the time quantum. So time slice may expire. So at that time also we have to suspend the execution of the one process and we have to select the another process for the executions from the ready queue. Okay, so this is the role of the process scheduling. Now the part of the operating system that makes this choice, that makes the selections, that is known as scheduler. Okay, who is going to maintain everything about the scheduling, that is known as the scheduler. The algorithm used by the scheduler is called the scheduling algorithm. Now, the process scheduling is an essential part of the multi-programming operating system because there are multiple processes are there in the executions. So, if the multiple processes are there in the executions, then we have to select one process and we have to suspend the another process. Okay, because at a time only one process is there in the executions. That's why. Now, which are the objectives of the scheduling? Which are the goals of the scheduling? So first is what? The fairness. Fairness, that means what? The giving each process to the fair share of CPU. No one will say that I am not able to get the CPU. Okay. So each and every process will get the CPU for the execution. So that is what the fairness. Then next is the balance. Balance, that means keeping all the parts of the system busy and maximized. No any part will be ideal. For example, input output peripheral devices is there, CPU is there, memory is there. So process can occupy each and every part of the computer system, operating system. No any parts will be ideal. So that means what? It maintains the balance between all the parts of the CPU, all the parts of the computer system. Then next is the throughput. Numbers of processes that are completed per time unit, that is maximize. So it try to maximize the throughput. So numbers of processes are more after some defined time. So that after some defined time, how many processes executed, so that numbers is known as the throughput. Then next is the turnaround time. So turnaround time that should be minimized. That means the process, if the process need the 3 seconds for the executions and its turnaround time is 10 seconds, then what is that? This turnaround time is more. That means process has to wait more. So that means process will suffer from the starvation. So this cannot be happened. So turnaround time, time to execute a process from submissions to the completion. So always operating system, always the scheduling algorithm will try to minimize this turnaround time. Okay, then now what is the turnaround time? How you are able to find out the turnaround time? Whenever there is an example, when in exam it is asked that define the turnaround time. So how you have to define turnaround time? That means what? The process finish time minus process arrival time. You have to define the process finish time. From that you have to minus the process arrival time. If all the processes are at the time 0, then your process finish time is your turnaround time for that particular process. That we will see in the example. Now, next goal of the scheduling is what? The CPU utilizations. So CPU utilizations is more. That means it is a percent of time that the CPU is busy in executing of a process. Okay, so keeps the CPU as busy as possible. So CPU utilizations may much be more in this process scheduling algorithm. Then next is the response time. So time between issuing a command and getting the result, that is minimized. Okay, so response time should be minimized. When the process gets the first chance for the execution, that is the response time. For example, process arrived at the time 3. Okay, but it gets the CPU as time 7. So what will be the response time of that process? That is a time 7. Okay, and you have to minus the arrival time from the response time. So for that particular time, process have to wait. Got it? Then next is a waiting time. So amount of time a process has been waiting in a ready queue, and this also waiting time should also be minimized. Now waiting time is what? The turnaround time minus actual execution time. So you can define the waiting time for that particular process. Got it? Now, next is the process scheduling queues. So, which are the process scheduling queues? We are talking about the process scheduling algorithms. How scheduler will schedule the process. So, what will happen? There are the different types of queue in which process will wait. Okay, so process scheduling queue help you to maintain the distinct queue for each and every process states. Now, all of you are about the how many there are numbers of states we have for the particular process, whether it is in ready queue, whether it is in running, whether it is in blocked, etc. Okay, so process scheduling queues helps you to maintain the distinct queue for each and every process status. And PCB, that means the process control block, that all of you know. Now, all the process of the same execution states are placed in the same queue. For example, 2 or more processes are waiting for the input-output interrupt. So now they are in the blocked queue. That means now they are in the block status. Okay, so it will wait in the same queue. If one or more processes are ready for the executions, though, then they will wait in the ready queue. So similar kind of processes will wait in the same queue. Got it? Then next is therefore, whenever the state of the process is modified, its PCB needs to be unlinked from its existing queue, which moves back to the new state queue. So every time you have to change the PCB. So when we have discussed about the PCB, I told you that every time when process blocked or when process resume its execution, every time we have to change in the PCB. Okay, so PCB is linked with this process scheduler. Now, next is the 3 types of operating system queues are there. Which are those 3 types of operating system queues? First is a job queue, second is the ready queue, and third is a device queue. Okay, so total 3 types of queue is that. Now, what is the meaning of this queue? So let's learn. First is a job queue. Job queue, that means it helps you to store the processes in the system. When the processes are there in the execution, at that time they are put in the job queue. Now next is a ready queue. Ready queue, that means what? This type of queue helps you to set the every process residing in the main memory which is ready and waiting for the executions. That means when process are ready for the executions, at that time they are in the ready queue. When process arrives, at that time they are in the job queue. When ready, then it is in the ready queue. Then next is device queue. That means it is a process that is blocked because of the absence of the input output device. So when the process is blocked because of the input output peripheral device, at that time the process will be placed in the device queue, or also known as the block queue. Okay, so these are the three different types of queues that is in the process scheduling algorithm. So whenever the process will be scheduled because of this unblocked, because of block, because of input output interrupt, or because of time slice expired, so at that time the process will be put in this particular type of queue according to the process status. Now next is a process queue diagram. So here you can see the different states for the processes when they are in the executions. When the process arrives, so at that time the process will put in the job queue. But now the process will be select. Now process are ready for the execution. So at that time the process will be put in the ready queue. Now the process are ready. CPU will select any of the process if that particular process will get the execution, will get the CPU and completes its executions, then CPU will select the another process. Now suppose CPU will select the another process, and for that particular process if any input output request is there, so what will happen? If any input output request is that, so now the process will be placed into IO queue, and if it will get any IO devices and it completes execution, then again it will come to the ready queue. Now CPU have selected another process, for example its time slice expire. So if it time slice expire, again this process will go in the ready queue. Okay, and maybe possible the process has created the child. So if the process has created the child, process will go in the waiting state until and unless its child completes its executions. So again the process will be there in the ready queue. Now it wait for any interrupt to occur. So if any interrupt will occur, again it will go in the ready queue. So like this way process will continue according to its state, and again it will go in the ready queue, again it will go in the block state, as we have seen the process diagram. So same thing is over here. According to this different types of queue, process scheduler will schedule the process for the executions. Okay. So whatever I have explained, that is written over here. First step is every new process first put in the ready queue. So it waits in the ready queue until it's finally processed for the executions. So one of its process is allocated the CPU and it is executing now. And next the process should issue an input output request. Okay, so if it issue the input output request, it will go in the IO queue. So it should be placed in the IO queue. Then next the process should create the sub process. Okay, so the process should be waiting for its termination. So when the process creates its child, so then parent process have to wait for the child's terminations. Then it should remove the forcefully from the CPU. As a result interrupt, or once the interrupt is completed, it should be sent back to the ready queue. So these are the different steps for the process scheduling when the process are there in the execution. So at that time scheduler will select the process based on this different states. Now next is which are the different types of scheduler. So here you can see this is the different ready queue is there, then block queue, that means input output queue is there. So these are the three different types of the scheduler. Which are the scheduler? That is a medium term scheduler, long term scheduler, and short term scheduler. So long term scheduler will used when the process when we have to select process from job queue to ready queue. So at that time there is a use of the long term scheduler when the process will be selected from the ready queue for the executions. So at that time there will be the use of the short term scheduler. Okay, and after the process completes the execution, it will exits from the CPU. And if the timeout expire, so if timeout is there, time slice is there, so at that time the work of the medium term scheduler to schedule the process, and from medium term scheduler will schedule that process to the ready queue. And if any event occurs, so then again it is in block queue, so at that time also there is a role of the medium term scheduler to select the process. Got it? So these are the three different types of scheduler is there. Now let's have a look at this in detail. So first of all, three types of scheduler. So long term scheduler, it is a job scheduler. Then short term scheduler, it is a CPU scheduler. And medium term scheduler, it is a process swapping scheduler. So it may be asked that explain the job scheduler, then you have to explain the long term scheduler. Same way CPU scheduler, then you have to explain the short term scheduler. Now, long-term scheduler, it selects the process from the pool and loads them into the memory for the executions. Same way, short-term scheduler, it selects these processes which are ready to execute. So that's why it selects the process from the ready queue. Now, the medium-term scheduler, it can be reintroduce the process into memory and executions can be continued. Now, for the speed, long-term scheduler, speed is lesser than the short-term scheduler. And here in short-term scheduler, speed is faster among all the scheduler because it deals with the CPU. Because it selects the process when its time slice expire. It is a short-term scheduler. That's why its speed is faster than among all the schedulers. Now, for the medium-term scheduler, speed is in between the short-term scheduler and the long-term scheduler. Now, in long-term scheduler, it is almost absent or minimal in the time sharing system. Okay, and in short-term scheduler, it is also the minimal in the time sharing system, and in medium-term scheduler, it is the part of the time sharing system. So when time sharing system is there, the medium-term scheduler is also always present, and long-term scheduler, it is minimal use, so maybe it is present or maybe it is not present. Now, which are the scheduling algorithm? So here you can see these are the different types of scheduling algorithm is that. First is a first come first serve, that is FCFS. Then shortest job first. There are basically two types of it, preemptive and non-preemptive. Then next we will see the round robin algorithm. Then we will see the priority scheduling algorithm. Again it is the preemptive and non-preemptive. Okay, so today we have learned what is scheduling, which are the objectives of the scheduling. Then we have learned about the process scheduling key. Basically, there are three types of queue: job queue, device queue, etc. Then next is a types of scheduler. Okay, so this we have covered today, and in next lecture we will cover the process scheduling algorithm. We will start with the FCFS. So this is all about this lecture. Remaining interesting topic we will cover in the next lecture. Thank you for watching. We will meet in the next lecture. Thank you.